let's do question 5b1. It says determine dy dx if y is equals to 2x cubed minus 4x plus 5. Okay, so how do we do this? Right, remember we have to differentiate using rules here, and we differentiate each term independently. Right, how do we differentiate using rules? Remember that when we are given, maybe let me say a times x to the power n. Right, let me call this one f of x. Right, what is the derivative of this? How do we derive using rules? Okay, we multiply, we say the exponent times the coefficient. So it's going to be a times n. You see that? Exponent times coefficient. And then x to the power. And then what do you do to the exponent? You subtract 1 from the exponent, and then n minus 1. This is how we differentiate using rules. Okay, right, so when you're differentiating, it means our terms must be in this form every time. We're going to see that when we do question 5b2, we'll have to make sure that our terms are in this form. Okay, right, so now let's start with this term. So dy dx is equals to, and then what do we do here? The exponent is 3, the coefficient is 2. So we say 3 times 2, which is what? Which is 6. Okay, and then x to the power, and then what do we do to 3? We say 3 minus 1. Let me just do that before I give you the final answer. You see that? And then we're done with this term 2x cubed. And then we go to the next one, which is negative 4x. And then the exponent here is 1. This is the invisible 1 here. So you say 1 times negative 4, you get negative 4. And then x to the power 1 minus 1. You see that what is 1 minus 1 is 0. And then plus the derivative of a constant. Derivative of a constant is 0. You see that? Okay. Then we can simplify. Let's just write our final answer. Therefore, dy dx is equals to 6x squared minus, what is 1 minus 1 is 0, and the x to the power 0 is 1, isn't it? So we're just remaining with negative 4 there, and then 0 is 0. So we've derived here, and we're getting our 2 marks. Done. We're going to do question 5b2 in our next video.